In this video, we will be talking about the flat surfaces, how to actually plot them. So let's say we're going to use the normal function of the normal equation of the plane for flat surfaces. It's given by ax plus by plus cz is equal to d. So what's a, what's b, what's c, x, y, and z, you know, these are the coordinates. What is d? This is also here, you know. Okay, in order to actually understand what these are and what coordinate system we are gonna plot it, that's very important. Okay, let's say we have a local coordinate system. Why am I saying local? That's very important because it's a normal form equation. You have a plane and normal to that plane is passing through this origin, and I'm gonna call it as local coordinate origin, not the global one. So you can visualize this as, let's say there's a, now visualize a global coordinate system x, y, and z. You have a cube here. Okay, so it will have a local coordinate center system because the normal to these planes will be passing through that point. Okay, actually to assume it is actually parallel to this one. So when we are going to use normal, you just have to say that it's in local coordinate system. That's a very important thing. So like if we have a body, we are going to define it in local coordinate system. Its plane will be corresponding to local coordinate system. Then if you had just transfer it into global system, it would be easy. So let's say in global coordinate system here, its center is at xc comma yc comma zc, and this is like 0 comma 0 comma 0 in global. So in order to convert it in this form, you just have to write this equation here as a x minus xc plus b y minus yc plus c z minus zc is equal to d. So actually I have to talk about what is d also. So d is the distance of this plane with this local point, local center, or like this distance of this plane with respect to the center, that would be like side divided by 2, or in here if there is a body center, distance of that part. Okay, so this will be in the global system, and this would be in local system, local coordinate system. So how, if you don't know how to derive this equation and what are these ABCs also, okay, you're going to understand what are these A, B, and C's and D's if we actually gonna derive the equation of plane. So you have a local coordinate, you have a plane, you have a normal to that plane, and this is the normal vector. Okay, let me draw it nicely. So this is the normal to the plane, it will be 90 degree to this plane. Understand? So let's say there are 2 points, any 2 points. You can take any 2 points on this plane, P naught and P. Let's say there are 2 points and draw a line. Since this normal vector is perpendicular to this P1 P line, P naught P line, so what does that mean? That the dot product of normal vector with P naught P line is equal to 0. What is dot product? It's like n P naught P cos of theta, magnitude this, magnitude and cos of theta is equal to 0. Since theta is equal to 90 degree because it's perpendicular, so n dot P naught P is equal to 0. Okay, so let's say what's n. So normal vector, let me draw it in here to visualize. This normal vector is written as a I plus, let's say it's written as ai plus bj plus ck. So it's in I direction, j direction, k direction. So this is normal vector, so you would know that what a, b, and c's are. So you can write it, and it's p not P is actually a line that can be given as, let's say P naught, its coordinates are x naught, y naught, z naught, and P, the point has coordinate x, y, and z. So P naught P can be written as x naught minus x I plus y naught minus yj plus z naught minus z. Okay, so this is it. So you can dot product it, ai plus bj plus ck, dot product it with x naught minus x I plus y naught minus yj plus z0 minus zk is equal to 0. So in dot product, I multiplies with I, j with j, k with k. These are ones, others are 0. So likewise, it will be like x0 minus x into, and I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. So it would be like x0 minus x a plus y0 y multiplied by b c z0 minus z is equal to 0. Now you can just transfer one side x's, one side ax0 here, and just transfer this a x that side. So you will get an equation ax naught plus b y naught plus c z naught is equal to ax plus by plus cz. So this thing is actually equal to d, that is distance of the plane from the center of the body, and this is actually the equation actually written as. So ax plus by is equal to cz is equal to d is the equation of surface in normal form. Remember that normal form, local coordinate system, just keep it in mind. Okay, so let's see how we are gonna code it up. Okay, let's code a surface, and I'm gonna say a surface that is parallel to yz plane, this surface. And for this surface, what is normal? Actually, part like this normal is parallel to this x-axis, doesn't matter. So the a here would be actually, let's say a is equal to 1 2 3, you can put it anything. Let's say positive 1, let's put it positive 1. B, since it's parallel to yz plane, b is equal to 0, c is equal to 0. Let's put a d is equal to, from origin, let's say d is equal to, let's say 3. Okay, you got your inputs for one plane. Now you're going to write a function. As I have shown, function f would be given by ax plus by plus cz equivalent to d, and this will give you logical array. If you would have followed me, you would know. Okay, so after getting this function, now you will get a function f whose value would be 0 on the plane. Wait a second, let's say don't write it in this like this one. Let's write it cz minus t is equal to 0. Now this function would be 0, otherwise it would have been like d, because I put it equal to d. It would be 0 here, it would be positive here for positive a, and it would be negative in this side. Why I'm just writing these positive negative, showing you positive negatives, like greater than 0 would be here, less than 0 it would be here. This is important to actually plot a closed surface. You will understand later on that when I am going to plot or just visualize for surfaces, bodies, these pluses and negatives are important because they are used in Macaulay brackets. You will understand when I'm going to plot for two surfaces, more than one surface, you will see that these are important, these positive values, negative values. And as far as body is considered, like a cube, just remember function f is like negative here, 0 on the surface, and positive here outside. Okay, and after applying Macaulay, the inside will be also equal to 0. That will be shown later on. So let me focus here on the thing that it's 0 here, function negative here, positive here. So the function f ax plus by plus cz minus d is equal to 0. Okay, now what is the shape of this function? In Matlab we are going to use, that's very important. What is the shape of this function? It depends upon the shape of x, y, and z's. So we had first define x, y. As I have shown, we can use mesh grid for that. Mesh grid from initial point to final point, where this is like unit space apart. Okay, so you will get x, y, and z in 3D matrix. This will be 3D, as I have shown in mesh grid lecture. This will be a 3D how it will look like. So this function will also be 3D, and you have to plot a 3D matrix. So in order to plot a 3D matrix, you need a function that can plot a 3D matrix. So let me overview some of the functions used for different like data shape. So let's say we have overview. Let me give an overview first. Okay, this is 1D matrix, 2D matrix, and 3D matrix. But look at the function that will be used to visualize these plots. So if you have 1D matrix like this, 1 2 3 4, y is like 1 2 5 6, that will be also in 1D. So since it is for 2, you can use function like plot x comma y. For 3, you can use like plot x comma plot 3 for 3 data points. But it's for 1D matrix. You can also use 1D matrix can be used. Okay, there is alpha shape also, alpha shape. There is boundaries also. This you can plot in this one also. There is convex hull, plots with the data point as 1D matrix. Data shapes like 1D matrix, you can use these functions. There might be much more, you can actually see it in Matlab. For 2D matrix, x would be 2D, lots of rows, lots of columns like this, and y also would be like 2D, and z can also be like 2D. And for these you would need function like surf function, surf C for contour. Maybe there is also a contour there, contour surface is there. Okay, these are some of the functions that is used to actually plot for 2D grids. Now for 3D grids, grids x, y, and z would be like 3D. So this is 2D, or it catenated over another 2D. Why? Like this is one matrix, or it is another matrix, it's like 3D matrix. And for these that we need in our plotting the surface, we need this one, is we need to plot 3D. So how to plot 3D, that's very tricky. So there are lots of functions. The most important one is like volume viewer. It can take 3D matrix. Okay, this is an app in Matlab. It can be downloaded by downloading the image processing toolbox. We can also use slice. I will show you what slice also does. We can also use like iso surface. Okay, we can also use isocaps function to actually view 3D surface. But there's one problem with this thing, iso surface. I will show you, because iso surface actually plots the surface. So there is a body, is going to only plot the surface of this body, and that side will plot the surface of that body. It only plots surface if there is only, in our cases, there's only one surface at x3. So it will plot two surfaces, from positive side and from negative side. So as a surface is problem if you are going to plot only one surface. In your case, it's only one surface. If we're going to, for iso surface, you're going to plot two surfaces, not one. And it will be a distance of like unit divided by 1. Unit divided by 1. What unit I mean? When I said 1 to 10, the unit was 1. So it's going to plot at a distance of 0.5. So if it's at 3, so 2.5 and 3.5, it's going to plot two surfaces if you use iso surface. If you want to decrease the position, you're going to go 1 to 0.1 space between them, then it will be at a distance of 2.9 and 3.1. So like iso surface has this problem. You can actually visualize a volume and surface there by using iso surface. We're going to use iso surface to actually view in this video also. Volume is the best one to actually view a 3D matrix. For that you need image processing toolbox, iso caps, slice is there. Slice is also important one to actually, we're going to visually see how to actually visualize the 3D surfaces. Thank you for watching.